Hello everyone, welcome to my YouTube channel Understanding Concepts. Our today's topic is logic gates. A logic gates is not any type of a device actually, and it's a circuit that works on some logic. So, logic gates are the circuits those works on some logic. That's why these are known as the logic gates. We are having different types of logic gates, and we are categorizing all the gates into three different categories, that is the basic gates, universal gates, and exclusive gates. So under the basic gates we are having three different gates, that is a NOT gate, AND gate, and OR gate. And under the category of universal gate we are having two different gates, that is a NAND gate and a NOR gate. And in the third category, exclusive gates. As you know, the exclusive means something special. Exclusive is special, so you will be having two special gates, that is a EX here for the exclusive OR gate. You can simply write it as XOR gate. And the second one is exclusive NOR gate, or you can write it as XNOR gate. We will be discussing all these gates in detail in today's session. And one more thing I want to clear you, that if whenever you going to write the name of the gate, that is a NOT gate and gate, you have to write it in the capital letters only, NOT, or all in the capital letters, AND all in the capital letters. So NOT, and OR are the basic gates. NAND and NOR are the two universal gates, and exclusive OR and exclusive NOR are the two exclusive gates. So starting from the very first category, that is a basic gates. As we know, here we are having three different basic gates. That is first one is a NOT gate. When we are going to explain the NOT gate, the first one we will be considering is a um, symbol. This is the method how to draw a symbol for the NOT gate. Here we are having a triangle shaped symbol with the circle, small circle, and this is called a bubble. This is a bubble, and this is a symbol for NOT gate. This gate is having any of the, in fact, any of the logic gate may have one or more than one input and output. So NOT gate will be specifically having a single input and a single output. Here the input A is denoted by A and output is denoted by Y. So the relation of the Y, that is the output and the input, will be equal to Y is equal to A bar. You can also write it as A dash. So what it is meant, like when you will be putting any input to the NOT gate, the output you will be getting will be the complement of the input. So that's why we are here taking the formula that Y is equal to A bar. Bar means the complement. So what it meant exactly is, here you are having, you can see here, this is a table and this is known as a truth table. Why this is called a truth table? Because all the values mentioned in this table, those are the inputs and corresponding outputs, are always true. So that's why this table is known as a truth table. So here we are having the input and output. Basically we are going to like relate the input and output relations in this table. For the NOT gate, we are having a single input, that is a, and the output, that is Y. Sorry, it's Y. So we are having a output Y. We are having two basic options of the um, input. We may provide a input because it's a digital gate, so we can provide a 0 or we can provide a 1. We are having only two options. So if we are providing 0 and at the input, then obviously the output will be the complement of the input. That means if we are providing 0, the output will be 1, and if we are providing 1 at the input, the output will be 0, right? I can write it with some other color so that you can like you can find it clear. So if you are providing 0 at the input, the output will be 1, and if you are providing 1 at the input, the output of the NOT gate will be 0. So coming to the second gate, that is a AND gate. The symbol you have to draw is like, here you are having a vertical line, here two horizontal lines like this, then you have to make it like a curve over here, arc type shape. Then this is a AND gate. Here you will be having two inputs and a single output. The inputs are denoted as A and B, and the output is Y. So the relation of the input and output, that was the formula for the AND gate, will be Y is equal to A and B. Basically A and B means here, um, as we are having two inputs of the gate, corresponding one output is there, so there will be some relation. So I am just going to tell you through a circuit that how this AND gate will be creating the outputs according to the input. Suppose we are here having example circuit over here, like suppose you are having a source over here, and suppose you are here having, in this simple circuit you are having two switches with the bulb connected over here like this, and now this circuit is being like this. Suppose this switch is A and this second switch is B. Now we know that at the input we will be providing only 0 and 1. So suppose if we are providing 0, that means the switch is open, and if we are providing 1, then the switch is closed basically, right? So so we are having here the four options, that is the four different ways in which we can provide the inputs. The first option, maybe we are providing A is equal to 0, B is equal to 0. We will be considering four different cases. So the first case is A may be 0 and B may be 0, both inputs are 0. Then if the 0, then 0 means open, that means the this switch, first switch A is open, B is open, that means we have connected the source with the circuit, but still there is no connection between the source and the this load. So that means basically no current is going from the source to the load, so that means this bulb will not glow. Not glow, that means the output will be 0. That means if we will be providing 0 0 at both of the inputs of the NAND gate, at the AND gate, then the output will be 0. And now suppose in the second case we are providing A is equal to 0 and B is equal to 1. That means we are A is equal to 0, that means now switch this is open, but we have closed this switch. We have closed this switch. Now still you can see, as this switch A is open, that means there is no direct connection between the source and the this bulb load. That means the bulb will not glow. So when A is equal to 0, B is equal to 1, bulb is not glowing, that means still the output is equal to 0. And considering the third case, that one A is equal to 1 and B is equal to 0, that means now we are just switching this A switch closed, and this is still open because B is equal to 0, so B is open. That means the circuit is still not completed because there is a connection loss in the B switch. So the bulb will not glow. That means if A is equal to 1, B is equal to 0, then the output is still 0. So and the fourth case, that is A is equal to 1, B is equal to 1. 1 means closed. So that means in this fourth case, switch A is closed and switch B is closed. Now both of the switches are closed, and there's a complete circuit formed. That means now this bulb will glow. So when A is equal to 0, B is equal to 1, sorry, A is equal to 1, B is equal to 1, then the output of this AND gate will be 1. Basically you can see now, to when we want this switch to be glow, like this bulb to be glow, then switch A and switch B both should be closed. That means if we want the output of the AND gate as 1, then the we want the output of the AND gate as high, then the A and B inputs both should be high. And A and B, when A and B both are high, then the output is high. When both are low, then it's 0. When one is low, one is high, then it's 0. When one is high, first one input is high, second is low, then it's 0. But if A and B both are high, then the output is high. That's why this is known as a AND gate, right? So coming to the next gate, that is a OR gate. Now for the OR gate, here for designing a symbol, then we have to make a curve like this, then just a curve, one more curve, and here too for one more curve. You have to make it in this way only, the curves, three curves you are joining like in this way. And this is a symbol for OR gate. Here we are having two inputs, input A and input B, and having a single output, that is Y. And the relation between the outputs and the inputs will be Y is equal to A plus B. Now again, I'm just going to explain this AND gate in with the help of this circuit. Now we'll be having a circuit like this. Suppose we are having a source, and now again we are having two switches. Now we have connected the switches in this shunt manner. Previously in the AND gate we are having the switches in the series. Now we are having two switches in parallel, and this is a switch A and this is a switch B. And now here we have again connected a bulb like this, and this is a circuit. Now you can consider again the same four input cases, and for the 0 it is open, and for the 1 the switch is closed. Now suppose A is equal to 0. We are now going to consider a first case. A is 0, B is 0. That means A is open, B is open. If both of the switches are open, there will be no connection between the source and the load. That means this bulb will not glow. That means here the output will be 0. When A is equal to 0, B is equal to 0, the output is 0. Now you can consider A is equal to the second input option, maybe A is equal to 0, B is equal to 1. That means A is still open, B is 1 means B has been closed. Now you can see that in this parallel connection, this is a circuit loss. Like there is a connection loss, there is not circuit completed, but through the B switch the circuit is completing. So if we are switching the B only, switch B only, even then the bulb will glow. That means if A is equal to 0, B is equal to 1, then output will be 1, right? So in the third case of the input, when A is equal to 1, B is equal to 0. Now A is 1 means we are switching off, we are closing this switch, and we are taking this B assuming as open. Now this is open, that means there is no connection, but this is closed because A is 1. So this is closed, that means there will be a complete circuit. So now the bulb will glow. So if A is equal to 1, B is equal to 0, the output will be 1. Now A is 1, the fourth case. A is 1, B is 1. So now in this case, fourth case, we are closing both of the switches. A is closed, B is closed. Obviously now the circuit is being completed. That means now the bulb will glow. That means the output will be 1 in case of A is equal to 1, B is equal to 1. So these are the three basic gates. The NOT gate, that will be having a complement of the input. If input is 0, then the output is 1. If input is 1, the output is 0. The second gate, AND gate, it is having a function A is equal to Y, Y is equal to A into B. That is A and B. So the relation of the input output will be, if both if both of the inputs are A and B are high, only then the output will be high. Otherwise in any of the case the output will be low. And in the OR gate, you can see in the OR gate the relation is Y is equal to A or B. This is a OR operation, A or B. A or B means if A or B, any of the switch is closed, even then the bulb will glow. That means if one of the input is, if one of the input is high or the both are high, then the output will be high, otherwise it will be low, right? So coming to the next gates, that is that those are the universal gates. We are having two different universal gates. The first universal gate is a NAND gate, right? So what is NAND basically? As you can see, NAND is a combination of NAND and NOT. This and NOT. So it's being a NAND gate. So NAND gate is a combination of AND gate plus NOT gate. So we will be making a AND gate, symbol of AND gate, and then making a symbol of NOT gate. And by combining both of these, what we can do is we can have a symbol of AND gate with the simple bubble. Then this will be a symbol of AND gate. Without bubble, it's a AND gate only, but when we are going to add the bubble of a NOT gate, then this will be a symbol of NAND gate. So the relation of the input and the output will be over here is, what we are doing is, when we will be providing two inputs a and b, first of all it will be AND operation, that is y is equal to a and b. But after that there is a NOT gate that will be complement, that will take the complement. So the symbol will be like this, and the operation will be y is equal to a and b and complement, right? A and b for the AND gate and complement for the NOT gate. So symbol will be the combination of both, and the relation will be the combination of both AND gate and NOT gate. So when we will be discussing the relation between input and output, then suppose a and b. So suppose I'm just taking those truth table of AND gate here for the reference. Like here this was a AND gate table. So it was a y is equal to ab, then a is 0, b is 0, then the bulb will not glow. But in this case, if a is equal to 0, b is equal to 0, first of all you will be getting a 0, then after that the complement, right? Here the AND gate was having the output a is equal to 0, b is equal to 0, output is 0. But in this case, in the NAND gate, you will be taking the complement also, so the output will be 1 over here. So in the second case, AND gate is having a 0 input and 1 input, the output is 0. But in the NAND gate, you will be taking the complement again, so the output will be 1, right? So in this case, if 1 and 0 input, the output is 0. But in the case of NAND gate, after the complement, the output will be 1. And in the AND gate, you was having 1 1, at the 1 1 input, the output was 1, high. When a is high, b is high, output is high. But in this case, you will be taking the complement of this, that will be low. So this is the truth table for the NAND gate, that is, at the 0 0 input, the output is 1, at the 0 1, the output is 1, at the 1 0 input, the output is high even, and at 1 1 input, the output is 0. So considering the next gate, universal gate, that is a NOR gate. Again, the NOR gate is a combination of OR and NOT, or plus NOT, that will be OR. So this is a symbol for OR gate, and we have connected a NOT gate also. By combining both of this, we have made this, we have just connected a bubble with the OR gate. So this is a symbol for NOR gate. Again, same as we were having a like we were having a relation in the OR gate, y was equal to a or operation b. But in this case, we will be taking a because here is a bubble, we will be taking a complement also. So for the NOR gate, the expression will be y is equal to a or b complement. So again, for the relation of the outputs and the inputs, so we will be again comparing this truth table of the OR gate. Here, when the inputs were 0 0, then the output was 0. But in this case, in the case of NOR gate, we will be again taking the complement, that means the output will be high over here. Here in the OR gate, we are having the inputs 0 1 and the output is 1. But after taking the complement, in case of NOR gate, the output will be 0. So here, as we are having the inputs 1 0, the output is 1, that is high. But in the case of NOR gate, after taking the complement, the output will be low. So in this case, when we were having input 1 1, the output is high. But in the case of NOR gate, when the output is 1 1, after taking the complement, of this output, the output will be lower in the case of NOR gate. So these are the two universal gates, and in this case you can say in the NAND gate, the if the both of the inputs are high, then the output is low. But if both of the inputs are low, or even the one of the input is low, then the output will be high. But if both of the inputs are high, then the output will be low. And in the case of this NOR gate, if both of the inputs are low, then the output is high. But if both of the inputs are high, or even one of the input is high, then in all of the cases the output will be low, right? So the third category, that is the special gates. So special gates are the two special gates we are having: exclusive OR gate, that is a XOR gate, and exclusive NOR gate, that is a XNOR gate. So here the symbol is, we have to draw a symbol like a OR gate, but we are having here the double arc, the curve over here, again a curve, join these two curves. So it's a exclusive OR gate. Here we are having two inputs, that is A and B, and here having a one output, that is Y. So the relation of the input output, that means the equation is Y is equal to A exclusive OR B. Now exclusive OR means this is a OR symbol, and we are having a circle around that, that is a symbol for the exclusive OR. So if we are going to elaborate this, then we will be having like this exclusive OR is equal to A. We can just have a bar and B plus, here this is a AND basically, plus A and B bar, right? So we are going to have the input of the output according to this expression actually. So when both the inputs are 0 0, A is 0, B is 0, then output will be collected from this. Like if both of the inputs are 0, A is 0, B is 0, then if A is equal to 0, we are just taking the first case. A is equal to 0, B is equal to 0, then putting the values in this, right? Y will be equal to A is 0, then A bar will be 1 into B is 0, that means B is 0. Here we are taking this, plus A, A is 0 into B is 0, and B bar will be 1. Bar means complement, right? So here Y will be equal to A into B, A and sorry, A into B matlab like you are having A dot B, like 1 dot 0, that is a 1 and operation 0, 1 and 0. What is 1 and 0 is, you will be getting here the 0 plus A and B. Here A is 0, B is 1, that is 0 and 1, that is again 0, and this is 0. So Y will be equal to 0, output will be 0. And in this case, by putting all the values, you can find that all cases. Like I am just going to solve the second one case, that is A is equal to 0 and B is equal to 1 also. So the second one case is A is equal to 0 and B is equal to 1. So putting again in this equation, Y will be equal to, first of all we have to take the A bar. A is equal to 0, that means A bar will be 1, and here B you have to take it as it is, so B here you will take in, plus A, what A is here 0, and B bar you have to take. Now B is equal to 1, so B bar will be equal to 0, and now by solving this, 1 into 1 is 1, plus 0 into 0 is 0, so this will be 1. So when A is equal to 0, B is equal to 1, the Y is 1. A is equal to 0, B is equal to 1, Y is 1. As you have to solve all the cases according to this formula, then the result will be when A is 1, B is 0, that will be 1 again. When A is 1, B is 1, then that will be 0 again, right? So the next gate, that is a exclusive NOR gate, or you can say it a XOR gate. Then the this is basically the combination of the exclusive OR gate and a NOT gate also. This is an exclusive OR gate and a no, NOT gate. So we will be having a exclusive OR gate with the bubble over here, and it's a symbol for exclusive NOR gate. You will be having two inputs over here and output. Inputs are A and B, and the output is Y. So the equation is y is equal to A exclusive B. This is A exclusive OR gate with the bubble. So you will be having a bar also. Y is equal to A exclusive B bar. Or you can, if you want to elaborate this formula, that will be equal to Y is equal to A bar into B plus AB bar, and for this whole bar, this. Now you have to minimize or simplify this formula, and after simplification you will be getting A B plus A bar into B bar. And how this simplification has been done, for that you have to check my lecture, the Boolean algebra and the simplification of the logic functions. I will be given the link in the description box. Also you will be checking the relation of the things, also how to simplify a equation. So now this is the simplified form, that is y is equal to A into B plus A bar into B bar. Now we will be finding the this relations of the inputs and outputs. We are having, suppose the first case we are going to consider. The first case is when A is equal to 0 and B is equal to 0. Now we will be putting the values of A and B into this equation. So y will be equal to, here A is A into B. A is 0 into B is 0 plus A bar. A is 0, that means A bar will be 1. B bar, B is 0, that means B bar will be 1. So just solve it. You will be getting like y is equal to 0 into 0 is 0 plus 1 into 1 is 1, that is equal to 1. So when A is equal to 0, B is equal to 1, the output of the exclusive NOR gate will be equal to 1, that is high. So considering this second case, when A is equal to 0, B is equal to 1. A is equal to 0, B is equal to 1. Again, I will be going to put the values of A and B into this equation. So according to that, y will be equal to, here A into B. A is 0 into B is 1, like this, plus A bar. Now A is equal to 0, that means A bar will be 1. Yes, and B is equal, B bar we have to take here. B is equal to 1, then B bar will be 0. So y will be equal to 0 into 1 is 0 plus 1 into 0 is 0 is equal to 0. So when we are having A is equal to 0 and B is equal to 1, the result will be, the final output will be 0. So other two cases can also be taken as this. So the output, when you are having here the input is, first input A is 1, B is 0, then the output will be 0 definitely. And if you are having A is equal to 1 and B is equal to 1, both are inputs are high, then the output will be 1 again. So in this case you can see, in the special case, gates, that is a exclusive OR gate, if both of the inputs are low or both of the inputs are high, then the outputs will definitely low. And if one of the input is low and one is high, then the output will be high. But in the case of exclusive NOR gate, you can have a relation like, if both the inputs are low or both the inputs are high, then the output is high. And if the one of the input is low and one is high, then the output of the exclusive OR gates is going to be low always. So this was all about the different logic gates. Again, we were having three categories of the gates: the basic gates, universal gates, and exclusive gates. So you can just have the idea, the logic gates from this lecture. And I will be definitely putting more and more videos. So you just stay tuned with us and subscribe my channel. Thank you so much.